Hello and good day, pre-algebra. Today we are going over calculating the probability of a single event. Okay. Yesterday we defined probability. Who can remind us what we defined it as? Ifan. Sure. The likelihood, and we're going to write it again, the likelihood of an event happening. Okay. We also yesterday talked about the scale of probability. What can you tell me about the scale of, of probability? What do we say? What does probability have to be between? Leah. 0 and 100, right? It is impossible to have something less than 0% chance of happening, and it is impossible to have something greater than 100% chance happening, okay? There's no such thing as extra credit when it comes to probability. There's no such thing as an improper fraction, okay? It's either not going to happen or it is guaranteed to happen. And then everything in between here, we talked yesterday about what it means for something to be 50%. There's just as much chance of it not happening as there is of it happening. We talked about the not likely range, which is kind of around that 25%. And we talked about the likely range, which is around that 75%. So those are kind of your standard probabilities there, but obviously, it can be anywhere between 0 and 100%. And the probability formula, this being a key point, you wouldn't necessarily need the scale on a help sheet, but I would definitely recommend putting the formula on a help sheet. And the formula for probability is the number of, let me change that. Okay. What you want to happen divided by what could happen. And that's kind of the layman's terms for it. Like, what do I want to happen? What could happen? Okay. So what you want to happen divided by what could happen. More mathematically, though, we would consider this to be the number of successful outcomes divided by the number of possible outcomes. And this is where PO66 comes into play here, because in PO66, we calculated the number of possible outcomes. That's what the counting principle gives us. So yesterday's objective focused on finding the denominator of this probability formula. Okay, but the number of successful outcomes divided by possible outcomes. So today we're going to be looking at how do we figure out what is successful, what do we want to happen, right? And then use our formula to calculate the probability of that event occurring. Okay? So let us begin with that task. Down here, we've got we have to write our probability as both a fraction and a percentage. We just got off our unit on percentages, and we saw that fractions and percentages are very much related. And then decide if the event is likely or not likely to happen. And we're going to show our work here. So you've got a bag of 60 marbles. 9 of them are red, 24 are blue, 15 are white, and 12 are yellow. You'll notice that 9 plus 24 plus 15 plus 12 is equal to 60. So that's good. Just check that. Okay. The first question, what is the probability of choosing a red marble? A red marble. So we're going to go to our formula, which is successful divided by possible. If we want to figure out the probability of choosing a red marble, the number of red marbles is what we consider successful. We pick a red marble, we've been successful. We don't pick a red marble, we're not successful. Okay, we didn't achieve what we wanted to test. So how many red marbles are there? 9. Okay, there are 9 successful outcomes in this bag because there are 9 red marbles, and that's what we're trying to calculate the probability of. And then how many marbles could we pick? How many possible outcomes are there from reaching into this bag and picking out a marble? 60, because there are 60 of them. Right? So here's our fraction. Here's our probability of picking a red marble. If we want the answer in fraction form, of course, we're going to simplify this. So divide 9 by 3 and 60 by 3. This gives us the fraction 3/20. What is 3/20 as a percentage? John. What is 3/20? Yeah. 15%. Okay, so here is your answer set there. Both as a fraction and a percentage, 3/20, 15%. And this came from looking at what was successful, the number of red marbles, divided by what's possible. We could pick any of the 60. The next one, what is the probability of choosing a yellow marble? Now we're considering a yellow marble to be successful. So our formula, successful outcomes over possible outcomes. How many successful outcomes are there if we're looking to pick a yellow marble? How many yellow marbles are in the bag? Okay. 12. So we have 12 successful outcomes. And our possible outcomes, does that change? No. We're still talking about our bag of 60 marbles here. So for a yellow marble, the probability is 12 out of 60. Again, we want to simplify this fraction. In this case, looks like dividing both by 6 is going to be the way to go. That gives us, no, divided by 12. Oh my goodness. Divide both by 12 to get down to 1/5. So you have a 1 in 5 chance. What is that as a percentage? 1/5 as a percentage. 20%. Okay. Now what this means, what this 1 out of 5 chance means, that if you were to do this 5 times, you would be expected to pick a yellow marble 1 of those times. Does that mean that if you do this 5 times, you're guaranteed to pick a yellow marble 1 out of the 5 times? No. This is just the probability of it happening. Things in life actually rarely go the way they probability-wise should. You know, that's why everyone loves the underdog, right? When a sports team beats a team they shouldn't beat, it's a big deal because, you know, it goes against the probability, but it actually happens a lot, you know. You could pick a yellow marble all 5 times. Not very likely to happen, okay? But this is just what you should expect to happen. Okay? In a couple objectives, we're going to be talking about theoretical probability versus experimental. Theoretical is what should happen. This is what should happen. 1 out of 5 times you should pick a yellow. Experimental probability is what actually happens when you do it, when you test it. Maybe you don't pick a yellow marble ever. Maybe in 100 picks, you don't pick a yellow one. Okay? It doesn't match what should happen, but it's what actually happens. So we'll get more into that coming up here. The next one, what is the probability of choosing a blue or a white marble? This word or is important because now it links the blue and the white marbles together. Now we're saying you are successful if you pick a blue one or a white one. So how many successful outcomes are there? How many successful outcomes are there, Leah? How'd you get 39? Exactly. If our successful outcomes are blue or white, there are 39 total blue and white marbles. We obviously can't pick a blue and a white one at the same time if we're only picking one, but a blue one or a white one is considered successful. So there's our probability, 39 out of 60. Divide both these by 3. That's going to give us 13 out of 20, which means that if we attempt this 20 times, we should theoretically get a blue or a white one 13 out of those 20. The other 7, we'd pick a red or a yellow. Right? But as a percentage, what is 13/20ths as a percentage? All these friendly denominators, by the way, 25, 20 again, John? 65% is correct. So of these 3 that we've done so far, which is the most likely to happen? The most recent one, right? The blue or the white one. It's got the highest percentage. And also notice, it's got the most successful outcomes, right? 39 successful outcomes compared to only 12 and 9. It's going to be the most likely to happen. Okay. Go ahead and calculate the next one on your own. The probability of choosing a red, white, or yellow. So now we have a lot of successful outcomes here. Red, white, or yellow. What is the probability of that occurring? And then if you're feeling good about things, you want to go on to the next page, you can do that as well. Question? Or answer?
For the next page, are we including Y's as
well? Y is not considered a vowel in this situation. A, E, I, O, U, and sometimes Y. This is not one of those sometimes. I'll pause the video while you work. Whoop, don't stop sharing though. Pause the video. Okay, and we're back. We have that one finished here. 60% is the answer. 36 successful outcomes simplifies to be 3/5, not 3/20, which is 60%. Okay, your homework then is going to be the second page. Let's just kind of preview it a little bit. Calculate the probability of each event, both as a fraction and percentage. You need to show your work, so I need to see your formula. Okay, the work that I need to see here is your successful divided by your possible. The letters of the alphabet, of which there are 26, are placed in a hat. So on the first page, our possible outcomes was always 60, because there were always 60 marbles in the bag. Right now, our number of possible outcomes is what? 26, right? Because there are 26 letters in the hat. What is the probability of choosing a vowel? Okay, your successful outcomes here is how many vowels there are. Right? What is the probability of choosing a consonant? Your successful outcomes here is how many consonants. What is the probability of choosing a letter A through N or S through Z? So your successful outcomes is how many letters are there from A to N and then from S to Z. Kind of like on the first page where we had blue or white, right? You had to add the blue ones, add the white ones. Okay, we're doing something similar here. And then, what is the probability of choosing any letter in the phrase SVDP Royals? Okay, your successful outcomes are the number of letters in SVDP Royals, but be a little bit careful here. This one might throw a little curveball at you, so just be paying attention. Yes. Yes. All right. Aiden.
Is it letters or it's characters?
Says letters.
All right.
Yeah.
So space wouldn't be included?
No. No. Space, question mark, whatever, they are not letters. Okay, then the second part here, the bottom half, says you flip a coin five times. What is the probability of getting all 5 heads? So here's where we really need to look at, back in PO66, how many outcomes exist. Okay, the probability of getting all 5 heads, well, events and outcomes here, okay? We've got flip 1, flip 2, flip 3, flip 4, and flip 5. How many outcomes exist? How many outcomes could there be on flip 1? Aiden?
2.
Attaboy. Good. 2. How many outcomes could there be on flip 2 and only flip 2? Aiden?
2.
Yes, we got it. How many outcomes could you get on flip 3 and only flip 3, everybody? 2. How many outcomes on flip 4?
15.
No, 2. And how many outcomes on flip 5? 2. Okay, so total now, how many outcomes exist in all? The counting principle says if we flip a coin 5 times, there are 2 times 2 times 2 times 2 times 2 number of outcomes. What is 2 times 2 times 2 times 2 times 2? What? Someone said it? 32. Okay, so there are 32 possible outcomes. That's going to be our denominator of our fraction, right? Our probability fraction is successful divided by possible. We had to go back to PO66 to figure out how many possible outcomes are there when we flip a coin 5 times. But it turns out there are 32. That's going to be our denominator. How many of those 32 outcomes is getting all 5 heads?
5.
No. How many of those outcomes is H, 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 H? Just 1, right? There's only one way to get all 5 heads. And this is where a probability tree might be helpful in showing you what all those outcomes are, but that's going to be a lot of branches, okay? So you have to kind of think through and say, well, all 5 heads, that's the outcome of H, 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 H. There's only one way to get that. So your probability is 1 out of 32, which you would then write as a percentage. Okay? And in this case, to get the percentage, I would just take 1 divided by 32 in your calculator, right? Because that's what a fraction is. Okay? The second question here, what is the probability of getting 4 heads and 1 tail in that order? So now, this phrase in that order is pretty important. We're looking for getting heads, 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 tail. Still 32 outcomes, right? Because we're still flipping the coin five times. Our denominator doesn't change here. But how many ways are there to get a heads, a heads, a heads, a heads, and a tail in that order? Aiden?
1.
Just 1, right? That's the only way it can happen. So it's going to be the same probability as the first one. The next one, what is the probability of getting 3 heads and 2 tails in that order? Similar thought process as number 2. And then what is the probability of getting 2 heads and 3 tails in that order? Similar thought process again. And then the last one here, without doing any calculations, is it more likely to get 1 head and 4 tails in that order, or get 1 head and 4 tails in any order, and explain why? Again, without doing any calculations. All right? So this page, the rest of PO67, is homework for tomorrow. If we still get numerous people not doing the homework, we'll go back to the flipped classroom. Okay? That was kind of your deal with me when you try to talk me out of it. You said, we'll do our homework. We'll do our homework. Please don't do this. So do your homework. Okay? Get it done. All right. That's how you math. Thank you.